How's it going? My name's Dim, and in this episode, we will be adding a few more API endpoints to our file storage web app, BigBox. In the last episode, we got Firebase auth working. In this episode, we will be verifying user requests to protected endpoints like deleting files or retrieving a user's uploaded files. There won't be any diagram this time, just code. With all that said, let's jump right into it. First off, we're going to give users the ability to delete a file they uploaded. To do this, a delete HTTP request will be made to /files/:id. Here, I'm just copying some code from the get method to retrieve our file from the database. Instead of selecting the file like we did in the get method though, we'll be deleting it. This is a good start, but this means anyone can delete any file. We want to restrict this function only to the user who uploaded the file in the first place. To do this, let's get the user's Firebase auth access token. My preferred way of doing this is by sending the authorization header. So that's what we'll do in our backend by making a call to context.getHeader. Copying over the code from our post method to verify the access token, we are just going to use our header instead of our form value as we did in the other request. Now that we have the user's ID, let's use that in our file struct. Since this ID is not a primary key, we will have to add our own where clause using the where method in GoPG. The question mark you see there gets replaced by authToken.uid after it's been sanitized by GoPG. However, I end up getting rid of this entirely because although it would delete the file and verify that the file is owned by that user, it would not provide useful error messages. I want to tell the user whether the request failed because the file doesn't exist or if they're not authorized, or if an internal state error occurred. By jamming everything into one delete statement, we lose this information. So eventually I go back to select using just the primary key and do a check in our backend to see if the file's user ID matches the requester's ID. If it does, we will delete the file in our database and check for any error. If there is no error, we will return an HTTP 204 status response code. This code is useful when a server operation was successful, but the server has no information to send back. Now, if the file's user ID did not match the requester's user ID, we can respond with an unauthorized status code. Here, you can see me debating between using abort with status or just status. This honestly doesn't matter much since we're not writing middleware, but I am still not sure which one to use, so just go with whatever you feel like. And here you can see me just cleaning up a bit of code and finally deciding to use abort with status. And we're good. Let's test out our endpoints. Let's try signing in. That works. Let's try uploading a file. That works. Let's try viewing a file. That works. Now let's try deleting that file. I don't yet want to implement that in the browser, so I'm just going to launch up Insomnia, which is an HTTP REST client that allows us to quickly create requests to test out our endpoints. I'll leave a link to it in the description. My version is a bit outdated, so it might look different from yours. Anyway, we're going to create a new request and write our URL in the top bar. We're also going to fill out our authorization header with our access token. You can either console.log this access token or find it in the request header on Chrome. Let's change our HTTP method to delete since that's what we want to test. And finally, let's paste the file ID into our URL. Firing off our request, we get a 204 no content. This should mean that our file was deleted. Refreshing our page in Chrome, our request now gets a 404. That sounds about right. Let's test it out again with a new file. Removing our authorization header, you see that we get a 401 unauthorized. This makes sense since we're not sending any credentials. Awesome. One thing you might want to do is delete files from the disk when they're removed from the database. I don't do it in this episode, so I'll just leave it as a challenge for the viewer. Let me know how it goes. Since we're soon going to be implementing a way for our users to see the files they uploaded, we need an endpoint that lets them retrieve their uploaded files. Let's create that right now. I'll just call the endpoint /files and figure out who the user is based on their authorization header. I don't want users to figure out what file other users have uploaded, just their own. Once again, let's just copy that code for decoding the user's access token from the authorization header. If you'd like, you can make these lines middleware so you don't have to keep writing them, but I won't be doing that in this episode. Now that we have access to the user's ID, let's fetch all of their files. To do this with GoPG, we need to initialize a file slice like so. We can call db.model and files to allow go-pg to modify the value of our file slice. Let's use the where method to filter only the user who made the request. Just like before, we are using the question mark here to ensure that all input is sanitized and safe to be sent to our database. Let's just add a quick error check in case anything went wrong with the request. Here I use status code 401 unauthorized, but in hindsight I'd prefer status code 500 service unavailable. Anyway, let's just send the user all the file data from the database and test it out. To do this, I'll just go over to Insomnia again and make the request that way. As we can see here, when we don't provide an authorization header, the server tells us we are unauthorized. So let's copy paste our access token from the console and see what happens. Nice. We can see all the files we've uploaded. Uploading a new file, we can see that that file is now being sent when we request /files. Something I just want to test is making sure some users don't see other users' files. To do this, I'll open a window in incognito, which will cause the user to be signed in anonymously. We can copy their access token and send it as the authorization header to see what happens. As we would expect, it's null instead of an empty array. This is mostly just a Go thing. Let's use make on our file to create a 0 length slice and test this out again. Awesome, we're now getting an empty array. Changing our authorization header back to the signed in user, we can once again see all the files we've uploaded. We do have a problem though. At the moment, we are sending every single file a user has uploaded back to them. If the user has uploaded thousands of files, the strain on the database and the size of information sent back to the user will be pretty large. Also, it doesn't really make sense because usually the user just wants to see the last couple files they uploaded and not every single one. To improve this endpoint's behavior, we want to restrict the number of rows being sent to the user. This is where pagination comes in. Think about when you go to Amazon or Google and search up something. At the bottom, there is a number of pages that you can go through. It can range between 1 and 1,000 or even more. The bulk majority of the time, you don't even go past the first page because you don't need any more results. We are going to do something similar. Let's accept a query parameter called page. This will be any non-negative integer, such as 0, 1, 2, etc. Each page will have a number of files, say 20. If the user is on page 0, they will see the first 20 results. If the user is on page 1, they will see the next 20 results, and so on. Anyway, to parse this parameter, we'll be using strcon.a2i, which converts ASCII strings to integers. If there is an error, we can just ignore it and make our page 0. Also, if the user sends a page less than 0, let's just clamp our page value to 0 to avoid any odd behavior. We are also defining a constant items for the number of items that will be returned for each request. Now that we have that, let's go to our SQL query. We'll be adding limit and offset. Limit does what you would expect. It limits the number of rows that can be returned to a certain number. Offset makes it so that you skip the first however many rows. For all our pages, the limit stays the same, since we never want to return more than 20 rows. The offset, however, is what's changing. On page 0, our offset should be 0 because we don't want to skip any results. On page 1, our offset should be 20 since we want to skip over the first 20 results. On page 2, 40, on page 3, 60, and so on. We achieve this by just multiplying our page number by the number of items per page. With these two functions, we should have achieved pagination. Something I did overlook was the ordering of rows, but we'll come back to that later. Let's just test out our pages. As you can see, page 0 returns the files we've uploaded and page 1 returns nothing. That makes sense, but I want to be more sure. Let's reduce our number of items to 2 and see what that looks like. Alright, page 0 returns the first 2 files, page 1 returns the next 2 files, page 2 returns the last 2 files, and page 3 returns nothing. Awesome. Now, for the final endpoint we'll be implementing, you may remember from a previous episode me mentioning that I want an anonymous user who is signing in to have their files migrated to the signed in user account. I think this is a nifty feature for people who forget to sign in before uploading something, so let's implement that. Let's call the route login and let's accept a JSON body. This JSON body will have a from and to property. The from property should hold the access token of the anonymous user we are signing in from. The to property should hold the new access token of the non-anonymous user that is being signed into. To do this, we'll instantiate an unnamed struct and use the context.bindJSON method passing in a pointer to that struct. BindJSON may error, so we have to check for that. Now let's copy our lines of code that decode the access token, and instead of using the request form value, we want to use the JSON's bodies fields. Now let's copy our lines of code that decode the access token, and instead of using the request form value, we want to use the JSON bodies fields. Something I do here is check if the from field was left empty. If the user is signing in from nothing, then there is no action to perform and we can return early. Now we want to write an SQL query that finds every column with the old user's ID and update the user ID to be the new user ID. To do this, we'll use GoPG, passing in an empty file struct. We will select all the rows where the user ID is from authtoken.uid and update those rows' user ID to be the to authtoken.uid. Here, you'll see that I go back and add a check to make sure the user we are signing in from is actually an anonymous user. We would not want to move files from one Google account to another Google account, at least not yet. The way we do this is by checking the sign-in provider of the auth token to make sure it is anonymous. Similarly, we want to check if the user we are signing into is not anonymous. With that out of the way, we can check for any error Postgres may have returned and return the status code of 500 to the user. If everything went well, we can respond with status 204 no content to show that the operation was successful. That seems good. Now let's test it out. Here I clear site data so that we are signed out of our Google account. I refresh the page and we are now authorized anonymously. I upload a file and go over to the REST client to check it out. That seems to work. Now, I create a new request and rename the requests to keep them organized. With this new request, I will see the files of my signed in account. So let's sign in once again and get our access token. Let's copy that access token to our REST client and check what files it has. Hold on, our pagination is still just 2. Changing it back to 20, we can see all our files. Now, let's make a request to our login endpoint. It will be a post request with a JSON body. For the from field, I'm just going to do something strange here, which is use our Google sign-in auth token. Here, I'm just trying to make sure that only anonymous users' files can be transferred to a non-anonymous user. We paste in our Google sign-in auth token. Now, for our to field, we paste in our anonymous sign-in auth token. Let's hit send. And we get a 401 as expected, since the from token has to be an anonymous user and the to token has to be a non-anonymous user. Let's just swap these tokens around. And we got an internal server error. Looking at the console, it seems like our update statement is not doing what we wanted, which is setting our old user ID to our new user ID. It turns out that we were supposed to use set first and then call update. We weren't calling set, and passing the strings to update does nothing. That was a silly mistake. I also change update to update not 0 so that we don't try to overwrite all the fields with 0 values from our file struct. Anyway, now that we've corrected it, let's run our code. Alright, 204 no content. Did it actually work though? Let's see. Okay, so our anonymous sign-in has no files, and our Google sign-in has one more file. Perfect, just what we wanted. Anyway, that's it for now. I hope you've gained a deeper insight into using ORMs, writing a backend with lots of features, and using an HTTP client to test out your backend before the frontend has been made. In the next episode, we'll be building on our frontend and give users the ability to quickly view the files they've uploaded and delete them with one click. Anyway, thank you for watching, and until then, stay tuned and peace out.